Hello, Matt Davis here with more homework quiz help. This one is from section 7.2. Suppose that a random sample of size 391 will be taken from a population where the proportion of successes is 0.8307. Determine the probability that p hat is greater than 0.80 and round your answer to 4 decimal places. So in the interest of giving help rather than answers, we're going to change the sample size to 381, and we're going to change the question from what we have here to the probability that p hat is greater than 0.82. So the process will be the same, but the answer will be different. All right, so how are we going to find the probability that p hat is greater than 0.82? Well, my hope would be that we would do it using area under a normal curve. If you're going to do that, you need to have a normal distribution. So we can check that real quick. So n is our sample size. Sample size was 381. P is the probability of a success in the population. They said that's going to be 0.8307. And Q is the probability of a failure, or 1 minus P, so 0.1693. So there's our NP and Q. And in order for P hat to be normally distributed, we need NP and NQ to both be bigger than or equal to 10. So the key is n times the smaller one. So in this case, n times q is 381 times 0.1693. And if that's greater than or equal to 10, then NP will be as well. And they didn't actually ask us to verify this, so I'm just doing it kind of the quick version. So NQ is 381 times 0.1693. So suppose n was 100 and we multiplied it by 0.6193. That would move the decimal over 2 spots and give us 16. 16 is bigger than 10. We're not multiplying by 100, we're multiplying by 381, so we're going to get something even bigger. So without my calculator, I can see that NQ is bigger than 10. And then NP is also going to be greater than or equal to 10 because we're multiplying 381 times an even bigger number. So what does that mean for us? It means that p hat is approximately normal. So when we want to find this probability for p hat, we can do so using area under a normal curve. But which normal curve are we going to do or use? We're going to have to use the one for p hat, which means we need to know the mean of p hat, which is equal to p. So that's 0.8307. And then we need to know sigma of p hat as well. That's equal to the square root of p times q over n. So that would be the square root of 0.8307 times 0.1693 divided by our sample size, which was 381. So that's a little bit messy, so we'll go to the calculator, get our answer, round it to 5 significant figures. So let's take a look at that. So we want the square root of 0.8307 times 0.1693 divided by 381. Make sure that you don't end the parentheses until you've got all 3 numbers in there. The square root is of the whole fraction. If you end the parentheses too soon, you won't be taking the square root of all 3 numbers. When we press enter, we get 0.0192126.865. We need to remember that 0 at the beginning of a small decimal number does not count as a significant figure. So our first significant figure is the 1, and then the 9, and then the 2, and then the 1, and the 5th one would be the second 2, which is followed by a 6. So we'll round that up and make it 0.19213. So let's go back and do that. So sigma is approximately 0.019213. So 1, 2, 3, 4, 5 significant figures, making sure that we remember that these lead zeros do not count as significant figures in that answer. All right, so that's all prep work. Now we can actually start answering the question. So we're going to use area under normal curve. So we'll draw a normal curve in here. This is going to be a normal curve for p hat. So in the center, we would put the mean of p hat, which is the population proportion of 8307. And then go back and look at the question we're trying to answer right there. The probability that p hat is greater than 0.82. So that's what we want to put on our picture. 0.82 is smaller than 0.83, so I'll put the 0.82 over here on the left. But we're trying to find the area to the right. Highlight this 3 times. So we're trying to find the area to the right, which means that we want to do greater than 0.82, which is the right of 0.82. So let's go shade that in. So we're looking for this area on the right-hand side. So whatever that is, that's going to be the answer to our question. So we want to find that area, but to do that, we need to convert from values of p hat to values of z. So I'm going to take this 0.82, calculate a z-score for that. So 0.82, our boundary, minus the mean, 0.8307, divided by the standard deviation for p hat, which is 0.019213. So we'll go get that z-score on the calculator. Remember, parentheses around numerators, so 0.82 minus 0.8307. Close the parentheses so that subtraction happens before this division. And then divide by the standard deviation, 0.019213. So negative 0.556. We round to 3 decimal places on z-scores. That 6 is followed by a 9, so we'll make it negative 0.557. So switching back over, negative 0.557. So that's our z, and we can use that to find this area. So we'll do normal CDF from our left-hand boundary, and our left-hand boundary is right here. Our right-hand boundary is over here towards infinity. So left-hand boundary, negative 0.557, always using z-scores. Right-hand boundary is infinity, and then we can go to the calculator with that. So one more time back to the calculator. So second and distribution, where you know our boundaries, we're trying to find area, so we use normal CDF, choice 2. And then our left-hand z-score boundary was negative 0.557. And our right boundary was infinity, so alpha I, assuming that we've stored a big number into the I key to have that represent infinity. And we get 0.7112, so that's going to be our answer. So 0.7112, always put in 4 decimal places on our probability calculation. So the probability that they wanted us to find was that area right there, which we just found. So final answer, this is what we're going to enter into active learning, 0.7112. Well, there was a lot that went on there, so there's a lot that could go wrong. Sometimes people will get the direction wrong when they're doing their normal CDF calculation. So when you're working right here, be careful to make sure that you put the left boundary, which is the negative z-score, and the right boundary, which is infinity. If you get them mixed up, you'll get a negative answer instead of a positive, so that should tell you something went wrong. Use some other visual checks. When we shaded our area, we shaded more than half of the area under the normal curve, so getting an area bigger than 0.5 makes sense. Our value of p hat, boundary value was 0.82. That was on the left, and we got a negative z-score, so that made sense. So we always want to think about those sort of things. Make sure you round your z-score to exactly 3 decimal places. Make sure when you do your standard deviation that you don't count those zeros as significant figures, and that you make sure you get 5 past that. So lots of issues there. Z-score needed the parentheses, all that sort of stuff. So hopefully in here somewhere you saw what gave you trouble, and I hope you get it right as you head back. So good luck to you.